In this video, I'm going to be covering the values of theta from trig ratios. So I came up with all the different possibility of all the trig ratios for our special angles. And our special angles are 0, 30, 45, 60, and 90. And in radians, we're looking at 0, pi sixths, pi fourths, pi thirds, and pi halves. So I'm going to be, for this particular video, I'm going to be using the trig hand trick. So if you are unfamiliar with the trig hand trick, then I would stop this video right now and I want you to YouTube trig hand trick. And then watch a video on how to do this. So the idea, well, I'm not going to explain it, I want you to watch the video. So I have sine theta equals 1/2. So I'm going to create this 1/2 using my hand trick. So from the sine direction, I'm going to put this finger down right here, and that's going to give me the square root of 1, which is 1/1/2. That gives me 1/2. So when I have sine theta equals 1/2, that means that theta has to be pi sixth. So theta equals pi sixth. Now, where is sine theta going to be positive? So here's my Cartesian grid here. And we have a pi, it looks like our pi then has been divided up into 6 different slices. So here is, we'll do this one as well. And there's going to be some human error in this. But the idea is that this rotation right here is pi sixth. And if you look, this other triangle over here, which also has pi sixth, should be symmetrical. Now, I didn't do a super good job constructing this, so it might be difficult to see that. Now, sine of theta, that's opposite over hypotenuse. So for this particular triangle right here, opposite is 1 over the hypotenuse. This triangle right here is the same size as this triangle over here, where we also have an opposite of 1 over the hypotenuse of 2. So that means then that our this is not a unit circle then, but that's all right. I think that the concept is still the same. So then that means that this rotation, I should use a different color, this rotation right here is my other angle, which is going to be, in this case, 1 pi 6, 2 pi 6, 3 pi 6, 4 pi 6, 5 pi 6. So I have 5 pi 6. Now let's look at the next one. This is cosine of theta. I'm going to recreate my cosine of theta equals pi halves. So that means I'm going to put this finger down here. I'm going from this direction here. I have one finger, so the square root of 1, which is just 1. 1 over 2 is 1/2. But the finger I need to put down is the pi thirds. So that means that theta is going to equal pi thirds. And if I draw my triangle then, that means that my pi is a half circle in radians. I'm going to divide it up into 3 slices. So we always start at the initial side. Here is here's pi thirds, and here's 2 pi thirds here. Definitely some human error. And then 3 pi thirds. So this rotation right here is pi thirds. So we have one triangle here, and we have another triangle here. Actually, because this is cosine, in this quadrant right here, this is going to give me, cosine is my x value, so that's going to give me a negative, this particular point here is a negative x value. So I'm actually looking at, for cosine, I'm looking at another triangle here. And this triangle here has the same base and the same height and the same hypotenuse. And in this case, our base is 1 and our hypotenuse is 2. So we have, this would also give us, this right here is also pi thirds. So the rotation from our initial side right here all the way around to here is going to be, let's draw another 60 degree here. So we have pi thirds, 2 pi thirds, 3 pi thirds, 4 pi thirds, 5 pi thirds. So we have 5 pi thirds. All right, let's look at another one. We have sine of theta equals the square root of 3 over 2. So for the square root of 3 over 2, for the sine direction, I'm going to put this finger down right here. So that gives me this 3, so I have the square root of 3 over 2. And that finger is pi thirds, so I have theta equals pi thirds. Now for this one, because it is sine, well, we're dividing up pi into 3 different slices. So we have something like this. Now sine, which is my y value, is positive. It's my y is positive in the first quadrant and the third quadrant. So this rotation right here is pi thirds. So this rotation here would be 1 pi thirds, 2 pi thirds. So we're looking at 2 pi thirds. Looking at the next one, we have cosine of the square root of 3 over 2. Cosine theta equals the square root of 3 over 2. So we're going to reconstruct the square root of 3 over 2. For cosine, that's from the thumb direction. So I'm going to put this finger down. That gives me the 3 fingers, the square root of 3 over 2, which means then putting down the pi sixth finger. So we have theta equals pi sixth. So pi sixth, that is 30 degrees. And we're looking for when cosine of theta is positive. And cosine, which is my x value, is positive in the first quadrant and the fourth quadrant. So we're going to, this is pi sixth, and this is pi sixth. So we're looking at the same triangle here. So when we start at the initial side, we rotate to get to this terminal side here, which is pi sixth, or we rotate all the way around to here. That will give us the same angle, which is what? 1 pi 6, 2 pi 6, 3 pi 6, 4 pi 6, 5 pi 6, 6 pi 6, 7 pi 6, 8 pi 6, 9 pi 6, 10 pi 6, 11 pi 6. So 11 pi 6 is going to be, theta for cosine is pi 6 and 11 pi 6. Let's do another one. All right, when is sine? Sine is my y value. When is sine going to be negative? Sine is going to be negative in the third. Recall that sine is my y value. It is going to be negative in the third and fourth quadrant. All right, so let's construct or reconstruct this idea of the square root of 3 over 2. So for sine, that's going to be from the pinky direction, so I'll put this finger down here. So now that gives me the square root of 3. I have 3, the square root of 3 over 2. But I'm putting down my pi thirds finger, so this is going to be pi thirds, so theta equals pi thirds. Actually, that's not even true because it's negative, so pi thirds though. So pi is going to be divided up into 3 slices, so here's 1, and here's 2. Let's do the same thing to the bottom. And we know that sine is negative in the third and fourth quadrant. So we're looking at these triangles here. And this triangle, this angle right here is pi thirds, and this one is pi thirds as well. So from our initial side, we are going to be rotating around to this angle, and we'll be rotating around to this angle here. So our first one, theta equals 1 pi thirds, 2 pi thirds, 3 pi thirds, 4 pi thirds, 4 pi thirds, right? So 4 pi thirds, and then one more, 5 pi thirds, 5 pi thirds. So again, this is our y value. If you recall, the sine theta is our y value. So you can see that the y value here is the same as the y value here. They are both negative. So it makes logical sense that we are going to be rotating all the way around to those terminal sides there. Let's look at cosine theta equals the negative square root of 3 over 2. So we're looking at the same thing, except we're looking at cosine, which is negative, whereas cosine, which is our x value, it is negative in the second and third quadrant. So what is the square root of 3 over 2? We will reconstruct that. For cosine, from the thumb direction, I need to put down this finger. So that's going to give me the square root of 3 over 2. I had to put down pi sixth, so this is going to be theta equals pi 6, which isn't really true because it has to be negative, so this is not even true. But let's go ahead and construct what this looks like. This is pi 6, 1 pi 6, 2 pi 6, 3 pi 6, 4 pi 6, 5 pi 6, 6 pi 6. We'll keep on going. Here, 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 and here. And we are going to be negative in the second and third quadrant, so that would be here. These do not look symmetrical, but oh well. So the idea again is that my adjacent and hypotenuse are the same for both of these triangles, but we always start at the initial side, and so we're going to rotate around to here where our cosine is going to be negative. So we have 1 pi 6, 2 pi 6, 3 pi 6, 4 pi 6, 5 pi 6. So theta equals 5 pi 6. And then 6 pi 6, 7 pi 6. We have 7 pi 6. So there you go. I don't know whether it's worth doing all of these. I think it might be a little bit too much, and the video will be way too long. We'll see. We'll see how much time we have after we're done with these ones. So I have sine of theta equals 1. So for my unit circle, here's my unit circle. Where is sine theta, which is my y value? Where is it 1? Well, right here we have 0, 1. So our y value is 1. Here this is our y value is 0. Here our y value is negative 1. So we're looking at just one value of this rotation here. So we're looking at theta being pi halves. Cosine theta, we can just look by inspection. We can see that when cosine theta equals 1, when our x equals 1, that is a rotation of 90 degrees as well. So this is going to give me, if we do a 90-degree rotation, that's going to give me cosine theta equals 0. So we're looking at this point right here, which is at 1, 0. So when our x value is 1, that's an angle rotation of 0. So this is going to be that theta equals 0 degrees. So I think I might have, let's see, is that, yeah. So this point right here, that's a rotation of 3 pi halves, so that this particular point here is going to be, that's going to be 0, negative 1, and this point right here is negative 1, 0. So let's look at sine. I'm going to use the same image right here to come up with these other ones. I have sine of theta, which is my y value. The y value equals 0. Here and here. Our y value equals 0 at here and here, which is a 0-degree rotation and a pi, or 180 degrees, or pi rotation. So theta in this case equals 0 and pi. All right, so we have cosine of theta. Cosine is my x value. My x value is 0 right here and here, so that's a 90-degree rotation and a 3 pi halves rotation. So theta equals pi halves and 3 pi halves. And then some of these other ones become a little bit more complicated. I'm just going to finish these ones over here. So just because they're easy. So sine of theta, which is my y, that equals negative 1 right here after 3 pi halves of a rotation. So theta equals 3 pi halves. Cosine theta, that equals negative 1 after a pi rotation. That gives me that my x value is negative 1. So theta equals just pi. All right, tangent. This one gets a little bit more complicated because we're talking about tangent. And if you recall, tangent of theta equals sine theta over cosine theta. So sine of theta is going to be, well, where are we going to get 1? That means that whatever sine of theta is, it equals the same thing as cosine theta, so that that the numerator and denominator, if they're the same, they cancel each other out, we get 1. And that only happens if this finger here is down, because that gives me the square root of 2 over 2 for my sine of theta, and then the square root of 2 over 2 for my cosine theta. So we're looking at sine of pi fourths. So that means that for our angle here, this is going to be that theta equals pi fourths. Now, is that the only time that sine theta is going to be, or tangent theta is going to be 1? Well, if we draw our Cartesian grid, tangent is going to be positive in the first quadrant, and it is positive also in the second quadrant, where sine is negative and cosine is negative. So I end up with a negative the square root of 2 over 2 over negative the square root of 2 over 2, which is going to give me 1. So we also have this rotation here as well. Well, if we take our pi and divide it up into 4 slices, then we have 1 pi fourths, 2 pi fourths, 3 pi fourths, 4 pi fourths, 5 pi fourths. So if we have 5 pi fourths, if tangent is 5 pi fourths, we also get 1. All right, so where is tangent going to be? Where's tangent of theta? Where's that going to give me negative 1? Well, if our positive tangents are in the first and the third quadrant, then our negative tangents are going to be in the second and the fourth quadrant. So we are looking at this rotation and this rotation here, which is going to give me that theta has to be 1 pi fourths, 2 pi fourths, 3 pi fourths. So I have 3 pi fourths, and 1, 2, 3, 4 pi fourths, 5 pi fourths, 6 pi fourths, 7 pi fourths. So we also have 7 pi fourths. All right, I think that this one is impossible, at least as a special angle, so I messed up on those ones. Let's look at this one. I actually meant to have one, I'm not actually sure what I meant to do. The square root of, I don't know. I'd have to re-examine those, and I'm not willing to do that during the video. So let's look at the next one. We have tangent theta equals the square root of 3. Well, if we're looking at special angles, that has to be we either have to be looking at pi sixths or pi thirds. That's the only way we're going to incorporate the square root of 3. Now, let's just grab one randomly. Let's do pi 6. So if I do pi 6, so that would be tangent's the same thing. Tangent of theta is the same thing as sine of theta over cosine of theta. Now, if I chose to do pi 6, then pi 6 is going to give me sine of pi 6 is going to give me 1/2 over the other direction of the square root of 3 over 2. The square root of 3 over 2, which is going to be, take the reciprocal, that gives me 1/2 times 2 over the square root of 3, and cancel these out, and I'm left with the square root of 3, 1 over the square root of 3. Now, if I want to multiply by 1, because the square root of 3 is not considered simplified in the denominator, so I multiply by 1 in the form of the square root of 3 over 3, and that gives me the square root of 3 over 3, which is not the same thing. In fact, I think that's what I meant to put here. So, oh well. So it turns out that had I put that in here, then my theta in this case would have been the pi 6, since I put that figure down. So it should have been the other way around. It should have been pi thirds. So this would be theta equals pi thirds. And we could reconstruct this if we want. Pi thirds, so we have sine, which is the square root of 3 over 2, over 1/2, and then the 2 should cancel out, we're left with the square root of 3. Now this isn't our only rotation, we also have another rotation if our pi is divided up into 3 slices like this, and tangent is positive in the first quadrant and the third quadrant, then we're looking at this rotation here and this rotation here. So we have pi thirds, and 1 pi thirds, 2 pi thirds, 3 pi thirds, 4 pi thirds. We have 4 pi thirds. All right, and when we do the same thing here, we just since we have this already built for us, when is tangent theta going to be negative in the second and the fourth quadrant? So we're looking at, and these were 60-degree rotations, right? So we have, in this case, 1 pi thirds, 2 pi thirds, 2 pi thirds, and 3 pi thirds, 4 pi thirds, 5 pi thirds, 5 pi thirds. I'm going to do one more, and then we'll call it quits. So tangent theta equals undefined. Well, when is tangent theta undefined? Anything is undefined as far as the fraction is concerned, when 0 is in the denominator. So I have something like tangent of theta equals some number over 0. Well, when does that happen? When is there some number over 0? So recall again that tangent of theta is our sine theta over cosine theta, and so I want cosine to be 0. When will cosine theta give me 0? When is cosine theta going to give me 0? So if we look at our Cartesian grid, here our cosine, which is our x value, is going to be 1. Here our cosine is going to be, at this particular value, is going to give me, this is 0, negative 1, 0, 0, 1. I'm thinking ahead of myself. This one also here is going to be 0, negative 1. And this point right here is going to be negative 1, 0. So we're looking at this rotation here. That's going to give me cosine theta equals 0. And this rotation here is going to give me a cosine theta equals 0. So this rotation here in degrees that will give me a denominator of 0 at this rotation here of pi halves, and this one here, 1 pi halves, 2 pi halves, 3 pi halves. So that would give me 3 pi halves. So there you go. I hope this video was helpful. I didn't cover everything, but I think the video would be way too long if I did. So have a wonderful day. And again, I hope it was helpful.